Okay, so we're down to the last video review, and we're looking at another little problem or blip in the road, and that's limits around vertical asymptotes. So what usually happens, and I'll just draw a little sketch on the side, is that as you approach this um, area of concern, which is the denominator, you're going to end up with a 0 in denominator, or a location where this is undefined. And typically in a graph, we'll see, here's my xy coordinate, we'll see a vertical asymptote that hits there. Okay, and so if I were to sketch this graph, I would have uh, a location. Actually, this is, I don't know if you kind of remember from back in the day, if you graphed the parent function 1 over x, you would have these little swoopy sort of things that went through. And if I were going to graph any value that is greater than 4 for x, it's always going to come out positive, and it's going to be this sort of swoopy location right here. If I were to graph um, any location that is x is less than 4, then it would be a negative value, and it comes down to this sort of swoopy location like this. We're actually going to get into graphing these, and so this isn't something that I expect you to remember right now, but that is a unit that we'll cover. But as you can see, what happens is that on the right-hand side, this graph is approaching positive infinity, and on the left-hand side, this graph is approaching negative infinity. And so that's what our job is going to be, to figure out what's happening on either side. Well, let's jump in and do the limit. So if I do the limit by standard or by direct substitution, I would end up with 3 over 4 minus 0, where I just plug that, or 4 minus 4, which is 0, which is undefined or unbounded, and typically we say that the limit does not exist there. But again, this is really a correct answer. But again, sometimes we're really interested in what's happening on either side. Or as in the case of 46, again on my camera it's not easy to see, but hopefully on your paper you can see, I want to know what's happening on one side only. And so this undefined or does not exist answer, although a correct answer, is not necessarily what I'm always looking for. Okay, so what we're going to do when we get an undefined or does not exist, instead of sketching a graph, which is not always the most efficient method, it can go pretty quick. It didn't take me too long to do that graph. But we have another way to look, and it involves making a small table. And we've used tables before. But what I want to do is I want to check on the left of 4, and I want to check on the right of 4. Just this tiny little table to the left of 4 and to the right of 4. And what I'm going to do is I'm going to get very, 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 very close to 4, and I'm just going to approximate what's happening. Because all I need to know is this a negative value as I get really close to 4 on the left, or is it a positive value as I get really close to 4 on the left, and likewise on the right. So what I do is I envision here, I am taking something super duper duper close to 4, but just to the left of 4, and I'm figuring out what 3 over 3.999 minus 4 is. Now, that's a little math problem. You don't have to go through, you don't have to pull out your calculator and figure it out, because again, all I care about is whether or not it's positive or negative. And because 4 is just slightly bigger than 3.99, that means I'm going to get 3 divided by some negative number, and a positive number divided by a negative number is a negative value, and therefore this side goes to negative infinity. So on the left, it's headed to negative infinity, which is what my graph said, which is what I saw in the graph. But again, in lieu of making the graph, we can jump to a table. And so I'm going to do the same thing, but I'm going to approach it on the right-hand side. So again, I'm going to be looking at 3 over something a little bit bigger than 4, so 4.001 minus 4. And I know that I'm going to get a positive over a positive here, which is going to be a positive value, and that means it's approaching positive infinity. So again, it's just this little quick check that we're going to do to see where it's headed. So let's jump into one where it's just a one-sided limit. So if I have a one-sided limit, again, with standard or with direct substitution, I would do the value there. I'm going to change colors so it stands out a little bit more. Let's do, okay, so I would do 4 minus 1 over 4 squared minus 8 times 4 plus 16. That gives me 3 over 16 minus 32 is negative 16 plus 16 is 0. So again, we're undefined. This limit does not exist. However, we are interested in 4 on the left-hand side. What is happening as x approaches 4 from the left? That's what I'm interested in. I'm not really interested in that it does not exist. That doesn't help me. I want to know where it's headed. Is it dropping infinitely or is it rising infinitely? And so again, I'm going to go ahead and make that little table, except for it's really not a table anymore because all I care about is 4 on the left. That's all the limit asked for. Okay, so sometimes when I'm doing these where I'm checking the left or the right and I have something that I can factor, I like to do my math in factored form. Because of the way I'm doing it, it's very quick. All I care is if I'm going to get a positive value or a negative value. And if I'm plugging in 3.99999 here on the bottom, aside from taking my calculator and doing that, 3.99 squared minus 8 times 3.99, blah, blah, blah. Aside from doing all that, if I want to do this quick without a calculator, what I'd rather do is take a look at that denominator. So this is x minus 1 over in factored form. And so that would be x minus 4, x minus 4. Two numbers that multiply to be positive 16 add to be negative 8. So negative 4 times negative 4, that works. Okay, so now I'm going to put in that value. So I'll do a little bit more, or sorry, a little bit to the left of 4. So that's 3.999 minus 1 over 3.999 minus 4. And actually that's squared, so I can just write it like that. So 3.999 minus 1 is positive over 3.999 minus 4 is negative, but I'm going to square it, so it's going to be a negative squared or a positive over a positive, which means that on the left-hand side to the left of 4, this graph is approaching positive infinity. So again, the fact that it came up as undefined, something over 0, not the same as 0 over 0, not the same as the indeterminate form, not like when we have this red flag and we have to do algebraic manipulation. In fact, much nicer, we have an asymptote and we want to figure out what's happening on each side of the asymptote. Now, a lot of people ask, well, can't I just, if it's undefined, can't I just put does not exist? Well, that's acceptable in a lot of places. It's unbounded. However, again, there are going to be occasions where on the left and on the right, they're both going up to positive infinity or down to negative infinity, and some people will put that as an answer. Or in other cases, we're just looking at a left-hand side or a right-hand side, and if we're looking at a left-hand side or a right-hand side, again, that's what we care about. We care about where it is headed, not that it does not exist. We know that there's an asymptote. We want to know where it's going. Okay, so sometimes we're going to throw in some trig functions as well. And I believe this says pi over 2 from the left. So again, it's a one-sided one, so I'm only going to look at the one side. And I have this trig function of tangent. So like I said, graphing is an option, but graphing these rational functions is not always the simplest thing to do, especially when you get more complicated. And we'll get into how we do that again in another chapter. But sometimes a graph is the nicest thing to do. It's the nicest thing to look at. I can go to the left of pi over 2, but that's going to be, I have to figure out, okay, pi over 2 is about 1.57. So then I put in 1.56 and see what's happening. Again, in my calculator, it's not something I can necessarily visualize. So this is where I depend on a graph. I'm just going to go ahead and sketch a tangent function. Well, this is 2 and -2. Remember, those amplitudes are not even really applicable when we do that. I may have to look back at my notes for graphing a tangent, but remember that if there's nothing in front of the x, we always start by just breaking it down as the quadrants. Hopefully this looks a little bit familiar to you. 3 pi over 2. Also remember that tangent is sine over cosine. So when the cosine hits the x-axis is when I'm going to end up with an asymptote. And so I'll go ahead and sketch that parent function of the cosine in here. I should have done the little 5 points. Don't get sloppy. Do the parent function of the denominator, because when the denominator hits, again, that's when I have a vertical asymptote. I'll put those vertical asymptotes in there. Here we have one at pi over 2 and another one at 3 pi over 2. And I'm going to go ahead and graph my tangent function. Hopefully, again, this looks somewhat familiar. You remember tangent function approaches there. Here we go. Squeezed in the whole tangent function. I didn't even really need to graph that much of it because what I'm really interested in is pi over 2 from the left. So I'm going to look at pi over 2 from the left, and this one's going to positive infinity. And so again, sometimes the graph is more helpful to get an idea. All right, so let's do one last one where we are again looking at a one-side limit. I'm looking at the limit as x approaches -1 from the right. Okay, and so I am going to go ahead and plug that in. So I get 0 plus, -1 plus 3 on top, and then I have -1 squared plus 2 times -1 plus 1. That's going to give me 2 over 1 plus 2 plus -2, sorry, plus 1, 0. Again, this is undefined. The limit does not exist. But again, I'm interested in -1 from the right. So I'm going to go ahead and make approach -1 from the right hand, little kind of half of a table. I mean, it's really a lame attempt at a table. If I have to do both sides, it'll show up more because I'll see the left and the right. But this one is -1 from the right. So remember, when you're dealing with negative numbers, you're going to be plugging in. It sort of looks the opposite. The smaller the value of negative, the bigger the value is. I hope that sort of makes sense. So like if I'm going to be plugging in to the right of -1, just to the right of -1 would be -0.999. Just to the left of -1 would be -1.01. It's sort of the opposite of what we would think. So that's going to go over. Again, I have this denominator that I could factor. X squared plus 2x plus 1 is product of 1, sum of 2. So x plus 1, x plus 1. So on the bottom, I'm going to do -0.999 plus 1 squared. I'm going to end up with a positive over a positive squared, or a positive over a positive, and therefore I'm approaching positive infinity. So when I look at this solution, yeah, technically it does not exist, but where is this limit headed? It's headed to positive infinity, and that again becomes my answer. Positive infinity up here. This one does not exist. What's my answer? My answer is positive infinity. When I looked at this one, my answer was on both sides of that. Okay? So this is just sort of not terrible math, not awful math. It's just something that's going to happen, and we have to sort of check out what's going on, how it's working. Okay, so that's the last of the review. I hope that helped. If you chose to do this, I hope it made a difference. We're going to do a review on Monday, the Monday we return as well. That's a required one, so that'll hopefully be a little bit easier if you kind of follow along through this. But I hope you're enjoying your break, and as always, I hope to see you all soon.